Okay. So in our previous discussion, we have seen what is a thread, what is multi-threading environment. Then we have seen what is a thread. Then how do you create a thread? How do you create child processes in a multi-threaded environment? What are the other three classes that are used in our C sharp and .NET environment for handling or implementing multi-threaded programs? Now we are going to discuss how to schedule a thread. When I say scheduling a thread, we are going to fix a priority for a thread. We are going to fix priority for a thread. What do you mean by fixing a priority? When you have multiple threads are in the execution state, multiple threads are in the execution state. What do you mean by that? I have thread 1, thread 2, thread 3. All the three threads have been started. All the three threads have been started, but the processor can execute any one of the thread at a time, right? It cannot execute all the threads simultaneously. Concurrent execution cannot be done if you are going to have only one processor. That is one case. Or even though if you have multiple processor in your machine and all these processor need to execute the threads, there also you have to specify whether you have a thread which is having a priority higher than the other thread which is coming in. So when you have more than one threads coming in for the CPU cycle, or more than one threads are ready and waiting for the CPU cycle, by the time you may have to decide, the computer has to decide whether it has to execute the first thread, second thread, or the third thread. So if all the three are having same priority, if all these things are in the normal priority, then there is no problem. It can decide. The operating system will have its own threading policy. Based on that, it will decide, okay, I am going to execute thread 1 or thread 2 or thread 3. But if not, sometimes the programmer wants to fix, because I am the one who creates a multi-threaded programming, and in that case I will understand, or I know that how the threads are to be executed and whether any thread is having higher priority comparing to another thread. So in that case, what we are going to do, we need to set a priority to a thread. So we have already seen there is a property called priority which is used for setting or getting the priority of a thread, for which you have the priorities described as an enumerated data type. They are described as an enumerated data type called as thread priority. Thread priority is an enumerated data type which is used for setting the priority of a thread. And these are the different values available. Obviously, please recollect all the points that you studied under enumerated data type, how to define an enumerated data type, how do you give a name for the enumerated data type, how do you give values to the enumerated data type. All those points you have to recollect here. So this is the name of the data type and it contains these values: highest, normal, lowest, above normal and below normal. These are the priority values that you can set for a thread. Now when you have this thread priority enumerated data type, this is the order of the priorities. You have normal, so you will be having normal here at the center, and above the normal you will have above normal priority, and above that you will have highest. The same way, below the normal you will have below normal, then lowest. That is the order. So when you take the order of the priority, highest is getting the highest priority, then the second highest is above normal, third one will be normal, fourth one will be below normal, and the fifth one will be the lowest. This is the priority, right? I think I make sense. Highest, then below that you have above normal, below that you have normal, below that you have below normal, below that you have the lowest. So that will be the order of priority: highest, above normal, normal, below normal, lowest. This is the kind of priority that will be set. So that is what is described here. So the thread can be scheduled after threads with highest priority and before those with normal priority. So that means what? The above normal comes between highest and normal. Take below normal, the thread can be scheduled after threads with normal priority and before those with lowest priority. That means what? Below normal comes between the normal and the lowest. Then highest, obviously this is going to get the highest priority. Lowest, this is going to get the lowest priority, and normal is a default priority. This is the default priority. Note here, it is a default priority, and this is the thread will be scheduled after the above normal and before the below normal. So that means it comes between above normal and below normal. So this is how the priority will be set for the thread. And how do you set the priority? You can have the thread name, whatever child thread you have created, give the child thread name here, dot priority, property name, then thread priority is the enumerator data type, right? So that is how we give, right? When we created a colors enumerator data type, we have given colors dot red. That is how we get the value. The same way here we can give thread priority is the enumerator data type name, dot lowest is the value of the enumerator data type. So you assign the value something like this. So your thread priority defines a set of all possible values for a thread priority, and thread priority specify the relative priority of one thread with another thread, and every thread has an assigned priority, and the threads created within the runtime are initially assigned the normal priority. If you have not set the priority will be the normal priority, while threads created outside the runtime retain their previous priority when they enter the runtime. And the threads are scheduled for execution obviously based on their priority. Appa T1, T2, T3 in paranjittu 3 thread you are going to create. So let us say T1 is having the highest priority, T2 is having the lowest priority, and T3 is having the normal priority. Let us assume. If this is the case, if all the three are ready and they are waiting for the CPU cycle, so what it will do? T1 will be executed first, then it will execute T3, only then T2 will be executed. Why? Because T1 is having the highest priority, T3 is having the normal priority, and T2 is having the lowest priority. So based on the priority only, the CPU will be scheduling. And remember, please recollect the points of your operating system process scheduling. Process scheduling the base it is going to schedule. So when it is scheduling, it will consider what is the priority of each and every process, right? So based on that, here since it is a thread, the priority of the thread will be considered before scheduling. Now the scheduling algorithm used to determine the order of thread execution varies with operating system. So what kind of scheduling policy you have in the operating system, depending on that the threads will be scheduled, and the operating system can also adjust the thread priority dynamically as the user interface focus is moved between the foreground and the background. And the priority of the thread does not affect the thread state. Obviously it is not, the priority is not going to affect the thread state. So even if you have a lowest priority which is put in the wait state, that the state will not be affected by the priority. The state of the thread must be running before the operating system can schedule it. So these are some of the points that you have to remember when you discuss about the thread priority. And the last concept, just what is a thread pool? a pool is created to perform multiple processing simultaneously. So you will have group of threads that can be run simultaneously in the background. So generally these thread pools will be used in the server applications. I told you IRCTC example. So if you have a server running with many different tasks, for each task you can create a thread. Even in the remoting process, we have seen multiple client requests are coming in. So when you have multiple clients coming in the remoting process, what you can do, the server can create an object, and each object will be executed by a thread, and it will be waiting for the client request to be responded. So that kind of thing can be done using the thread pooling. A thread in a pool can be used for performing different tasks. And this is an example. You can have pulse object, and it notifies a thread in the waiting queue of a change in the locked object states. So these are some of the methods that will be used in your thread pool. And the wait will be releasing the lock on an object and blocks the current thread until it reacquires the lock, and it gets the number of milliseconds elapsed since the system started. So these are just some very vague points that I have just collected only for your examination purpose. If in case they ask you what is a thread pool, you can write up to this, and I think you need not write, you need not consider this particular slide. Just ignore the slide. Let us stop here itself. Thread pooling. What is a thread pool? If you are asked to write this thread pool and the methods what we have seen earlier in our previous discussion. We have seen what are the different methods available in the thread pool that can also be included, right? And I think please ignore all these things, because if I tell you what is a pulse, what is a wait method, and that may be confusing unless otherwise you know what is a background process, what is a foreground process, how the object can be locked. Apart from that, you have lot of other concepts also to be studied in the inter-process communication, etc. So only then we can understand all these things. So just ignore the slide and let us have the discussion till this point. Thread pooling, and thread pooling along with the methods of the thread pool can be included for your examination purpose also, right? So with that, we are completing the C# and .NET programming course of the 5th semester.